Okay, so part 3a of solving quadratic equations involves the concept of completing a square, and in terms of creating perfect square trinomials. So as a review, remember uh, the idea of perfect squares. So 4 is a perfect square because I can write 4 as some whole number squared. Um, 9 is a perfect square because I can write 9 as some whole number squared. 1 is a perfect square because I can write 1 as some whole number squared. 16 is a perfect square because I can write 16 as some whole number squared, and so on. So there is an infinite number of perfect squares. Okay, now, in a previous course, when you factored this trinomial, you factored it became x plus 3 times x plus 3, which we saw can be written as x plus 3 squared. So this trinomial right here was called a perfect square trinomial, just like these are called perfect squares. This would be called a perfect square trinomial because I can write this trinomial as an expression squared, as something squared. I can write 4 as something squared. I can write 9 as something squared. I can write this trinomial as something squared. So this trinomial is called a perfect square trinomial. Just like this one right here is also called a perfect square trinomial. So that's called a perfect square trinomial because when I factor it, when I go ahead and factor it, that's x minus 5 times x minus 5, which is x minus 5 squared. So I wrote x squared minus 10x plus 25 as something squared, a binomial squared. So this is called a perfect square trinomial because I can write it as a square of a binomial. Square of a binomial. Now I want you to notice something. See this coefficient of x right here, which is positive 6? If I take half of positive 6, which is 3, notice 3 here, and I square it, I get 9. See the coefficient of x here? If I take half of negative 10, so if I take negative 10 and divide it by 2, I get negative 5. See the negative 5? But if I square it, negative 5 times negative 5, I get a positive 25. So that's the idea you're going to use in a little while. So the question becomes this. So you know that these are perfect square trinomials because when I take half of 6 and I square it, I get 9. When I take half of negative 10 and I square it, I get 25. And when I factor it, I get x minus 5 squared, x plus 3 squared. And remember this positive 3 and this negative 5 you can easily get by taking half of this coefficient of x, by taking half of b. So the question becomes this. I have this expression x squared plus 8x plus some number. So the question becomes, what can I add to this expression? What can I add here so that this becomes a perfect square trinomial? So in other words, so that way I can factor it as a binomial squared. Well, just like we did here, look at the coefficient of x, so look at b. b is 8. If I take half of 8, I get 4. And if I square 4, I get plus 16. So half of 8 is 4. 4 squared is 16. And then I can factor this now as x plus 4 squared. So you can always check yourself. X plus 4 times x plus 4, FOIL it. X times x is x squared. The outer is 4x. The inner is 4x. And remember, the outer and the inner should be the same because these are the same binomials. And the last, a positive 4 times positive 4 is a positive 16. Combine like terms, I get x squared plus 8x plus 16, which is what I wanted. Okay? All right, so now, let's do this example. So the question will become here, let me go ahead and write this one. So this will be x squared minus 10x. So you have this binomial, and the question is, determine the constant. So determine the constant that should be added to this binomial, so that way it becomes a perfect square trinomial. In other words, what should I add here, so that way this becomes a perfect square trinomial. Now that's going to be important in a little while. So again, we take the coefficient of x, we take b in this case is negative 10, and I take half of it, so that's negative 5. Negative 5 times negative 5, in other words, I square negative 5, so negative 5 times negative 5 is a positive 25. All right, now, one thing I got to mention again. When I took half here, and when I took half here, and when I took half here, that only worked. That only works if the coefficient of x squared is 1. This must be a 1. This must be a 1. This must be a 1. So note, coefficient of x must, coefficient of x squared must be 1. Coefficient of x squared must be 1. So this is 1 right here. So since this coefficient of x squared is 1, I can take half of negative 10, square it, and there's my constant. So that's a perfect square trinomial because I can factor it, because I can factor as x minus 5 squared. Number 2. All right, suppose you had this. Suppose you had x squared minus 7x. All right, well, these were easy. These right here, those were easy right here because b was even 6, negative 10, positive 8. So the coefficients were all divisible by 2. Here, this coefficient is not divisible by 2, but the idea is the same. So, remember what we did. We took b and I divided it by 2. Once I divide by 2, I square. But remember, x squared must be 1. It is here. So since x squared is 1, I take b, which is negative 7. I divide it by 2. And then I square. And when I square, I get negative 7 times negative 7 is 49. 2 times 2 is 4. So that becomes x squared minus 7x plus 49 over 4. So there's your answer. So this is what you need to add. Now, this is a perfect square trinomial. Just make sure you understand this. This is a perfect square trinomial because I can factor as, all right, now, here's how you determine. A lot of students have trouble with the fractions. Okay, so basically all you do, guys, if you think about what we did here, remember, take half of 6, which is 3. Notice you get x plus 3. Take half of negative 10, which is negative 5, you get x minus 5. Take half of 8, which is 4, you get x plus 4. Now, you got to be careful. You got to make sure that when you square the 4 right here, when you FOIL it, 4 times 4 is 16. When you FOIL it, negative 5 times negative 5 is a positive 25. When you FOIL it, a positive 3 times a positive 3 is a positive 9. So over here, when I take half of negative 7, I get x minus 7 halves squared. And always check yourself. Always check yourself. Remember, you want to make sure you get this positive 49 fourths. Remember, when you FOIL it out, a negative times a negative is a positive. 7 halves times 7 halves is 49 fourths. That's what you wanted. Okay, so that's how you deal with the fractions. Okay, number 3, you have x squared minus 2/3 x. All right, don't make it difficult. Don't make it difficult. So you want to know You want to know basically what must I add here so that way this becomes a perfect square trinomial. All right, so just like we did here, we take the coefficient of x, so we take b, which is negative 2/3, and I divide by 2. I divide by 2. Now this is a little bit more challenging because this is a fraction. B is a fraction. Here, b, everything else, b was an integer. This is a fraction. But remember in a previous course how you divided fractions. So again, you take b, divide by 2. So you always change division multiplication, so that becomes negative 2/3 times the reciprocal of 2, which is a half, and then reduce, just like this, and you get negative 1/3. Okay, once you get negative 1/3, okay, remember, once you divide by 2, the next step is to square it. So once I divide by 2, I get this. The next step is to square it. And when I square, I get negative 1/3 times negative 1/3, which is a positive. Negative times negative is a positive. 1 times 1 is 1/9. So it becomes 1/9. That one is challenging. So I have to add 1/9, so that way this becomes a perfect square trinomial. All right, and then if you were to ask, and you will later on, if you were asked to write this as a binomial squared, then this becomes x minus. Okay, so here's what you do. You take this and divide by 2. So it's a little bit of work you have to do. Take negative 2/3, divide by 2. When I do that and I reduce, I get negative 1/3. It's x minus 1/3. And always make sure you get that positive 1/9. A negative 1/3 times a negative 1/3 is a positive 1/9. So that's what you have to add. That's what you have to add. You have to add 1/9. Okay, so that's the basic concept of 3a. So before we actually look at some problems involving, before we actually solve quadratic equations by completing a square, you needed to understand the idea of perfect square trinomials, and that's what this is. All right, so that's the end of part 3, 3a.